absolute value 2x minus 3 is less than or equal to 5. Okay, and this is very important. This is type, I call it type 1. It's the less than or equal to, or the between case. And the reason it's between case is because to drop the absolute value, you have to bring the 5, you bring the 5 straight down.
Mm-hmm.
You rewrite the 5 over here, but you make it negative. And then you bring what's in absolute value down next.
So, all right. So you're moving the 5, keeping that the same, and then
Yes, but you kind of put it in two spots.
so then -5 is greater than or is less than 2x minus 3. So do I just write this same exact bracket right there? Or well, not
No,
bracket,
no,
like arrow thing.
no. Like this is the new like line to solve.
Okay. So
Okay.
then would I?
So we want to get x by itself. And do you see how it's being subtracted by 3?
Yeah.
So you add 3, but you actually do it in 3 places here.
All right.
So on the left, it becomes -2 less than or equal to 2x less than or equal to 8.
So then, and then will I add 2?
Well, 2 is multiplying x. So how do you undo multiplication by 2?
Divide everything by 2.
You got to divide all 3 by 2. So you get -1 less than or equal to x less than or equal to 4.
Okay. And then would I make that -1 and 4 go together now?
No, that you're done. This is done.
Okay.
This is your
Oh wait, that's
final
kind of
answer.
like the just a faster way of kind of what I was doing before.
I see something on your paper here about breaking it up into 2 things, and you actually, this is called a compound inequality. So you leave it like this. Okay. Now you could be asked to graph the solution, but let's not focus on that. Let's just do another problem here.
All
Let's
right.
go absolute value 3x plus 4. This time I'm just going to get less than 7. Get less than 7 here. I should put a little more in the middle here. Okay, so step 1, you bring the 7 down and the inequality. You also bring it over here, but you make it negative.
Mm-hmm. And
then you bring this without the absolute value.
All right. And then you would
You subtract 4 from both sides of the equation.
right, and then you're like doing it in 3 spots. So then that's
-11 less
negative
than 3x less than 3.
3. And then you can't divide those.
You have to divide. Now it rarely works out nicely.
Oh, okay. That was like
So
the rare occasion.
you may get a fraction, and you may get an ugly fraction, something that isn't friendly, something you don't like what it looks like, but that is the nature of these things.
Uh-huh.
So don't shy away from doing it, because you definitely can do this. So
Okay, so I can have an odd thing like that and I'm fine.
yeah.
Okay.
Let's try another one here, because then we'll make them slightly more complicated. Let's go absolute value 2x plus 1 less than or equal to 9. I'd like you to try solving this one on your own, please.
Okay. So
And if I need to scroll up, let me know. I will do that.
oh good. I'll try and do this one out of memory. So, okay, one question. You don't need to scroll up. I keep it as 9 and I don't make it -9, correct?
The -9 goes to the left here.
Okay, so will it always just change signs?
Yes. Yes. We'll get into kind of the exceptions or the weird, the kind of the oddities.
All right, all right. And then All right, got it.
Okay, so you bring I'm gonna just show you the steps here in case you wanna look at it later. -9 less than or equal to, and then 2x plus 1 in between.
Mhm.
When you subtract 1, you subtract 1. -10 less than or equal to 2x less than or equal to 8. And then you divide by 2, divide by 2, divide by 2. So -5 is less than or equal to x less than or equal to 4. Is
Yep,
that okay?
exactly what I got.
Okay, now a couple of variations on problems that you might see. This is still this type where you have less than or equal to. For example, I could say 2 times the absolute value of x minus 3 plus 7 equals, I'm sorry, less than or equal to, I don't know, 13.
Mhm.
Okay, so this one is different than the previous ones.
So it's different because instead of just going,
You have to first isolate the absolute value.
so would I
Do you want to get rid of this added?
subtract?
Do you want to get rid of this +7 by subtracting 7
All
from
right,
both
and
sides?
then once I get that to absolute value x minus 3 is less than 6, and then would you divide that by 2?
Yes.
All right, and then that would just be x minus 3, or well, absolute value x minus 3 is less than 3.
Yes. And now this one is just like one that we've been doing, but there was a few additional steps to get to where you can do that.
All right, not too tricky yet. And then you just move the 3 over and then have minus 3 over there, and then you'd actually have to end up adding 3 to all of it. So then do you just want me to solve it real quick?
Yeah, I mean, you're going to bring the 3 down, the less than or equal to, and then the -3 like this. And then you put the x minus 3 there.
And then just divide all of, and then add 3. So then you'll have 0 is less than or greater to x, and then 6. So then are you able just to have 0 in that, or is there a rule with that?
That's okay.
All right, and then I guess I can't really think of a way to divide this one, so that's it, right?
No, there's nothing to divide.
All right.
It's done. X is by itself. See, X is alone. Okay, so let's look at another one here. Let's say it's a -3 absolute value x plus 4 minus 3 less than or equal to -9. Nope, I'm sorry. Well, let me change this. We got too many 3s here. And then, well, I wanted you to do this one, so let me change this to 5. So will you attempt this problem on your own, please?
Will do. And then, okay, I do have one question.
Okay, what
So,
is that?
so I have -6 is less than or greater to x and less than.
No. You got to add one to both sides, right? You did
Yeah,
that, I hope.
yeah, I did all that. So with that final part, I can divide.
You have to divide by 3. Yeah,
Yeah.
first. You have to
And
isolate the
then
absolute value.
Yeah, so I have like the answer, but
Okay,
so I have a -6 and then an x and then a -2. I can divide that by -2, but that doesn't apply for the x.
no, when you get X by itself, you're done. See how X
Oh,
is
okay.
alone? See
So
how it's
once
just
x is
X?
alone, oh, that's why you're dividing it because you're getting rid of the number in front of it. Like if that was -2x, I'd divide it by -2 because that can be applied to all the others and would isolate the x.
Yes.
Okay, cool. All right, that makes a lot more sense. X must be by itself. Or well, problem is done when x is by itself. Done when is by itself. Awesome.
Okay, so let's do another problem here. I'll make this one a little bit different. So -2 absolute value 3x plus 5 greater than or equal to -10. So at first glance, this appears to be different than the previous problem.
But all we have
But
to do is divide, right?
when you divide by -2, okay, 3x plus 5 less than or equal to 5. And now it's in the right form.
Mm-hmm. And then you can just continue the problem on like it's all the others.
Yes. So why don't you go ahead and try solving this one, please? It's a little bit different
All right.
from here.
Okay, well, I think I have my answer. By the way, if you're talking right now, I can't hear you.
Sorry, if I bring the 5 down and the -5 just like we did before, and then the 3x plus 5 in between. So you subtract 5 less than or equal to 0, divide by 3.
Mm-hmm.
So you get -10 divided by 3 less than or equal to x less than or equal to 0.
All right, that's exactly what I got.
Perfect. Okay, now we should move on to now the other type, okay? Because the other type I think is more confusing. Not sure why, but it is. So the next type is when you have greater than or equal to. Okay, and this creates a different type of problem. So let's say it's the absolute value of like 4x plus 3 greater than, I don't know, 6. Okay, so this time you make 2 forks, 2 paths.
All right.
Okay, and the first path is an exact copy of what you have written, except with no absolute value.
So, okay. So then that would just be 4x plus 3, 6. And then would the second one have absolute value?
No, the second one, you start by writing exactly the same thing. Okay, but then you flip this. So if this is a greater than, you flip it to a less than, and then you negate this.
Oh, right, because you need to have the opposite for it. It's like the plus minus 6.
Yeah, like I mean, just be careful. Yeah, just really be careful because if you go down the wrong road, it just you can get the wrong answer pretty quick.
All right. So then would I just subtract 3 on the one on the left?
Yep, you actually do the same operations in both cases. You just
Oh,
get
okay.
different numbers.
4x plus 9, 4x 3. And then isolate the x.
Yeah.
X. It's 9, 4. All right. Okay, cool. So I guess this one's just kind of like problems we've done before in a way.
Well, it's two approaches, and it's good that we're doing it this way with plenty of time so you can see the difference between them, because you really want to get it down to where you can, do these on your own. Let's put a 3 here, greater than or equal to 12.
Divide by 3, I guess.
Yeah, you have to isolate the absolute value. So you divide by 3, 2x minus 5 less greater than or equal to 4. This is when you can make the determination about what you were doing.
So then you can oh right.
Now,
So then
now you can break it apart. Now you can 2x minus 5 greater than or equal to 4. So you write exactly what's there. Like,
yeah.
and then on the right here, it's the left side is the same. You flip this though, so less than or equal to, and then 4 goes to -4,
And
or
4.
whatever number you get goes to -4, or whatever it is. And like I mentioned, you do the same operations everywhere, you just get different numbers.
And then okay. So I guess my question is with this is how do you graph all this?
Okay, good question.
Because I think that's the part I kind of struggled the most with.
Yeah, so let me have you do one problem on your own here, and then
That'd be a good
we'll
idea.
graph it. And then we can talk about that. So there's also some exceptions maybe to look at. Let's go -2, absolute value x minus 1 plus 3 less than or equal to 17.
All right.
-17. Sorry.
-17.
Yep. So I'll make a note here. When you divide by a negative, it does flip the inequality. So keep that in mind.
All right. Does flip the inequality.
Yes, when you multiply or divide by a negative.
Okay, my question is do I divide it by -2 or just 2?
Yes. -2.
Okay, so then does that make it +10?
Yes.
Okay.
So you're subtracting 3 like you did. You get -2, so x minus 1. And the key here is this is the step where you make a determination about what
how that all works out. Yeah, I just got the answers for this one.
okay. So this one is the two forks. So fork 1 is x minus 1 greater than or equal to 10. Fork 2 is x minus 1 less than or equal to -10. Is that okay?
Yeah, that's what I got.
And then you add 1. So x is greater than or equal to 11. Add 1. X is less than or equal to 11. All right, is that okay?
Wait, actually, I think that would be negative.
I'm sorry, -9.
Okay. Sounds good. That's what I got.
Okay, now the correct like reading of this would be x is greater than or equal to 11, or x is less than or equal to -9. And what's confusing about the way we have done it is that generally the smaller number is on the right and the bigger number is on the
Uh-huh.
left. So here's -9, here's 11, roughly. Okay,
Mhm.
I mean, you can be as exact as you want. These are not to scale.
Yeah.
So a couple things off to the side here. If you have a less than or equal to, greater than or equal to, it's a filled in dot. If you have a greater than or less than, it's a bubble.
Like bubble. All right.
Okay. Now you have greater than or equal to, so it's a filled in dot. And this literally means all the numbers bigger than 11. So that's all this stuff to the right.
And then
And this one is -9. This is all the ones to the left because it means all the numbers smaller than -9.
yeah, like just on for infinity.
Yes. Is
And
that
then
okay?
yeah, and then do I just make a line connecting you two?
No, 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 no. You've done it. It's all the
Okay.
numbers over here and all the numbers over here.
All right, cool.
Okay, so now let me. I think that what your real question is, and we got to do it. We got to do it very carefully here. We did some problem earlier that got down to, let's say, -4 less than x less than 3.
Uh-huh.
Do you like we let's just say we did a problem and this was the answer, okay?
All right.
The solution is, well, here's -4, here's 3. These are open circles. And this says all the numbers, let me write it out, all the numbers between -4 and 3.
Uh-huh. Oh, that's what X is representing.
Yes. All the numbers between. Now, let's say we did a problem now where the solution was x is greater than 3 or x is less than -4. Let's look at how that would be different.
So
So here's -4 and here's 3.
it would be a bubble and a bubble, and then it would be filling
I'm
out
going,
the lines to not with in between each other, but the ones outside of each other. Or that
exactly.
middle.
So I call this between, or maybe the word inside.
All right.
And this one I call the outside.
And that's the outside. All right.
Okay. So that's the first thing. Now,
I like that. And then,
what I should like, this is where I mean, if I could start over this lesson, I would do it slightly differently. When you get an absolute value of something less than a number, or an absolute value of something less than or equal to a number, whenever you have this case, the less than, it always produces the between case. And that means you're going to be your solution, you're always going to have two numbers and you're going to be graphing in between them. And this is critical. Whenever you get an absolute value of something less than, or absolute value of something less than or equal to, it's always the between case. Always, always, always.
all right. So less than, and then it's going to the right, and then that line saying that it's the line under it's being like, oh, this is it.
Yeah. So let me go back and graph our first problem of the day. And it's been long enough. You won't, you maybe have your notes, but let me have you solve and graph this. So I want you to first solve, then graph.
All right.
So since it's a less than, it's a Since it's a less than, you bring the 5 down and you put the -5 over here.
Uh-huh. And then you have to add 3 to all
Yes.
of them.
Right. So you add 3, you add 3.
2x, 8. And then you can divide all of that by 2.
That's right.
Minus 1, x, and 4.
So this is the between case. Here's -1 and here's 4. Are they filled in bubbles or are they not filled in bubbles?
Those are filled in bubbles.
They're filled in bubbles. And since it's between, it has to be between, has to be in the inside.
Between has to be on the inside. All right.
Okay, now let me go grab one that we did that was a greater than. Let me see if I can find that first. Okay, so we did this one here. Okay, when it's greater than or greater than or equal to, we have to make the 2 forks. So we're going to go and do this problem now. We're going to solve and graph. Okay, so the first fork is exactly what is shown without the absolute value.
So it's, and then the other one, the little like triangle, I can't remember its name.
Less than.
Less than is the other direction, and it's -6.
Exactly.
And then you subtract 3 on both of them, and that leaves you with 4x is greater than 3, and 4x is less than -9. Then divide both of those by 4, which gives you x is greater than 3 over 4, and x is less than -9 over 4.
Yes. Okay, now on the number line, -9 over 4, 3 over 4. You have to put them in increasing order. Obviously, it's -infinity to infinity.
So it would be going for 3/4. So it would be going to the. They're both open circles, and it's going to the right, and then the other one's going to the left.
Right. Notice this is the outside.
Outside, right, not inside.
Like I call it outside. I don't know. I feel like this is inside, that's outside. I mean, maybe you got better
that's like
words, you know,
that's like the safe. The in between's like the safe spot, and then the outside's whatever.
right? You know, you can think of it as, you know, maybe this is the singles and then doubles, you get a little extra room. I don't know, whatever.
Oh yeah, wait, that's actually a good idea to think about it.
You got to find ways to.
Oh, sorry, I think you just cut out.
Well, you got to think of ways to remember stuff in terms of something else that you already know or like.
Yeah, I always try and like make something like, I don't know, just car related or for school.
Yeah. Now you're driving now, right? You're on the road, or you're officially got your license and all that.
I officially have my permit, but
Okay,
I'll be having my license soon.
great, great.
Yeah, new
So
thread
that's
on the
awesome.
river.
Fantastic. Okay, so I do have a responsibility here to show you some of the oddities that you might see.
Uh-huh.
Okay, so I'm going to throw a few at you. 2 greater than or equal to absolute value x minus 1 plus, let me make this 12 plus 5.
All right.
This is not like any of the problems that we have done because you can see the absolute value is on the wrong side.
Yeah.
Do you see that?
So
You
should I?
still, you still solve for the absolute value, like you want to isolate it.
Uh-huh.
So you subtract 5 from both sides. And then you get 7 greater than or equal to x minus 1 like this. Let me know when you get up to this step here, because the next thing is very critical.
Okay. 12 greater than. 7. Okay, so with that.
So with this here, you have to rewrite it. You have to write it like this. And I'm just going to show you And I need you to look at it until you believe that they're the same. I need you to focus really hard on,
So I see how these are the same because you have your absolute value in the same spot, but the 7 has to be greater than, or is that
yes,
equal than, or
or the absolute value has to be less than. So the absolute value has to be less than.
yeah, better way to put it. So the 7, so when you switch over that 7, the triangle like flips with it in order so it stays the same.
Yeah,
And
I don't, I try not to use the word flip until you multiply or divide by negative. I call it kind of like pointing. It's still pointing at it
okay, that's a
or
better
away
way to
from
put it.
it.
It's pointing, like the little triangle is kind of pointing at x minus 1.
Yes,
So it's always
yes.
pointing at
Okay.
x.
So like it's not just that you have to solve for the absolute value. It needs to be on the left side of the equation. Now you're driving a car. What side of the car do you get in?
You get on the left side.
Right. And like you're comfortable doing problems like this. So you have to turn problems that aren't like this into problems like this.
All right. Yeah,
Okay, so,
yesterday, or not yesterday, 2 days ago, I was trying to do this and I just didn't understand that, but right now I'm glad I do.
right. So we really want all of our problems to be in some form like this: absolute value of something greater than n, absolute value of something greater than or equal to n, absolute value of something less than n, absolute value of something less than or equal to n. These are the only forms that you want to deal with.
Yeah. It's just
And
what,
the sooner you like the if you can get them into this form, it really makes a huge difference. Okay.
yeah.
So that's what you're looking to do. Now let's look at maybe another possibility here. -4 greater than or equal to um, -2 absolute value x plus 5.
-2 x plus 5. Okay, so what you're going to do is move that -4 over. Well, just you're kind of like swapping them all in a way. So you're going to make sure that we'll have -2 absolute value of x plus 5. And then you're going to make sure that it's negative and that it's less than.
Now it does flip. It does flip though. That's important here. And that's every so often thrown into this.
Uh, oh, okay. Yeah, I guess that just makes it more neat when you do it. And then you'll have the x plus 5, and then is greater than or less than 2. I mean,
So it ends
greater.
up looking like this. So maybe you said the right thing or the wrong thing, but like this is what it ends up looking like, and this is what you want. This is in
Yeah,
a
that's what I
format you
meant.
can.
What's
Okay,
what's it called when the little arrow thing has a line under it?
so you say greater than or equal to.
Greater than or equal to. All right, that's what I was trying to say.
Yes. All right, fantastic. So now I want you to solve and graph this. So
So,
take 2 minutes if you need, and
all right, got it.
okay. So here's what I'm gonna do. You tell me when yours is different than mine. So it's x plus 5 greater than or equal to 2, x plus 5 less than or equal to -2. Do you have this also?
Oh, shoot, I did it the other way.
What do you mean by the other way? Like between?
Um, I did it where I have, instead of making the
Like put,
two thing, like the two different lines, I just wrote it as -2 is greater than or less to
yeah,
then.
okay. So
And
yeah, that's really like before you do any problem, you have to decide, is it a type one or is it a type two or whatever,
What you
is it
wanna
a
call it.
forehand or a backhand? You've gotta know from the beginning, from this symbol right here, that it's a fork.
Okay. Shoot.
Yeah. And so, okay, let's go back and look at our lesson from the beginning. I did a type one less than or equal to. Then I did another less than. Then I did another less than or equal to. I think you did this one, and then another less than or equal to, and then another
Uh-huh.
one. Okay. And then another one. Right. And then I switched. I said, well, what if it's, well, actually, this was just then I switched and I said, well, what if it's a greater than?
Uh-huh. Then
Okay.
you have to make it with two digits.
Right. Right. And that's the key, Zach. That is the key to being successful in this part of the course is recognizing, is it this type or is it the first one that we did?
Mm-hmm. Okay.
So I'm not, don't hear criticism here,
Yeah.
that's the takeaway from this is that if you can't do that, or if you can do that, when you can do that, you're going to be really successful here. So um, whenever you get here ready, go ahead and solve these because it also affects what the graph looks like.
All right. So you'd be putting on, here, let me draw the little graph. You'd have the -3 and -7.
Where does the -3 go and where's the -7 go? Which is -3 and
-7
which is,
goes to the one on the left.
yes. Okay, very good.
And then you're gonna make it go um, all the other numbers. So that means that's all gonna be on the outside and not the inside.
Yes, and they're filled in because it's less than or equal to or greater than or equal to.
All right. And then for putting this on an actual graph, or
This
well,
is
not saying that's an actual graph, saying
this
something
is
where it's like a plus symbol is the best way to
you
describe
mean
it.
like this?
Yeah.
Okay, this is correct right down here. This is a one-dimensional problem.
Uh-huh.
There is no two-dimensional solution. You're thinking of something else that is either maybe you covered in class, but it's not part of this lesson.
Okay. All right. I guess I'm thinking of that for just a different type of.
Like here's what I think you're thinking of. Let's say y is less than absolute value x minus 4. So this has a v right here.
Uh-huh.
Actually, let me make it less than or equal to. And then you want everything that's less than it. So it's actually all this stuff on the underneath.
Mm-hmm.
Is that what you're thinking of?
Yeah, I think so.
Okay. If it is, that's coming up. Like you first learn one-dimensional absolute value graphing, and then you learn two-dimensional.
Okay, cool, cool. So then, all right, all right. I think I was just getting confused with like two things. That makes sense to me.
Fantastic. Yeah, I don't want to keep like, yeah, it's so critical that you get the right kind of, starting on
Right.
this.
Like you started right because it just
Yeah,
builds off it.
right. So the last kind of like I call these exceptions, which we haven't really talked about. Let's say you get this, the absolute value of 5x minus 3 is greater than or equal to -4. Okay. So this is an exception. This means there's something different going on here. So don't try to solve this. What this is literally saying is you take the absolute value of a number. This is always positive, because the absolute value always returns positive. Do you agree with that? Do you remember that?
Yeah, it changes it.
Okay. Yeah, but it's always positive. Like it doesn't matter. You're always going to get this. Always returns a positive or zero, I guess.
Uh-huh.
And you're comparing it to a negative number. See how this is negative over here?
Uh-huh.
Okay, so this is always true.
That outside
Like,
number.
well, no, like you can put any number you want in here and it will always be bigger than a negative number.
Oh, okay. Oh yeah, that makes
It's
sense.
always true. So this is actually infinite solutions or all real numbers.
All right. So then I just write that.
Yes. And like you have to be on the lookout for this. You have to be on the lookout for and it's either one of these forms, like the absolute value is something greater than or equal to a negative number, absolute value is something greater than a negative number. This is always true.
Always true. Okay. And then would I even solve that problem, or would I literally just write like infinite
No,
solution?
you're done. You're done. You're done. See, the problem is you're gonna get this on a quiz and you're gonna try to solve it and get something that is infinite solutions, and your instructor is gonna mark you off half and say, yeah, it's infinite solutions. You should have known that from the beginning.
Okay, cool.
Okay, now the other kind of exception here is, let's say I give you the absolute value of a 5 plus 6x less than or equal to -2.
Then
So again, think about what this returns. Like you can put any number you want in here, pick any x you want. It's always going to give you a positive or 0.
uh
Can a positive number be less than a negative number?
yes.
So like, here's what you're saying. I'm going to come out to the side here. You're saying 7 is less than or equal to -2. No. How about 1?
Oh
Is 1 less than or equal to -2? No. How about 0? No.
no,
So
that's always bigger. My bad. I must have misheard
that's
you.
okay. But that's this is the point of this, is like, these are exceptions. These are weird. They're different. So this has no solution. There is not a number you can put in here where you don't get something that is positive or 0. Positives or zeros are always bigger than this number on the right. So there's no way to make this true.
So then with
So
infinite
if
no,
this wasn't clear, I guess, I mean, just maybe just flush it out, the last 5 minutes, but these are the two
I guess
exceptions that
I
you'll see.
understand the infinite solutions, but I'm not positive if I understand the zero for no solutions.
Well, you've got to find a number where this is true. And like, this always returns a positive
Wait a
number.
second. Okay, that actually makes sense now because it's saying that a positive is less than a negative, which is
Yes,
false.
yeah, exactly. It's false.
Okay, I don't.
Right.
I said that like a minute ago, but I guess that didn't just click. But
My opinion is that if you were taking a test or quiz, you would receive one or both exceptions at some point. But
y-
just to be clear, I'm going to scroll up here to a problem we did earlier. Okay, that might appear to violate this, but it actually doesn't. Let me see how this might appear to violate it. This line right here.
yeah.
But you don't look at this line. You look at the one where you have actually solved for the absolute value. It's
Okay, so
disguised.
once you figure it out, like once you get it like cleaned up,
Yes,
that's when you show
exactly.
it.
That's when you make that decision. Okay, yeah, I'm gonna be able to do that or not.
So then for that one, it's a -1 and it's saying, oh, I'm bigger than +10, which is false. But since there's the absolute value, it's
But
+1.
there are some numbers, like 12 is okay, 13 is okay. So if this were greater than or equal to -10, it would be infinite solutions because all numbers would do that.
Uh-huh. Okay.
All right. Unfortunately, we do have to stop here. Again, if you didn't feel great about that last part, just flush it out and focus on type 1 and 2.
All right. Sounds
I
good.
appreciate you scheduling, getting on the schedule here. You're almost to the end of the class. You're doing great. So just keep up whatever you're doing.
All right.
All
Well,
right. Thank you, sir. I'll see you next time. Have a great night.
yeah, you too, Matthew. See ya.